All right, so let's go ahead and see if we can determine the polarity of a molecule and if it is polar or nonpolar. And again, what a polar molecule is, it's got a region of positive and a region of negative and separated by a certain distance. And so there's two criteria that need to happen. The first thing is that it must have polar bonds. And so when you're looking at if it's a polar molecule or not, it's got to have polar bonds. But it also needs to be the correct shape, because if you remember from carbon dioxide has polar bonds. However, the dipoles go opposite each other and they end up canceling out, and this ends up not being a polar molecule. And so not only does it need to have polar bonds, but it also needs to have either a lone pair on the central atom, or there must be different atoms that are bonded to the central atom. So it's got to meet those two criteria. So it's got to have polar bonds, and it's either got to have lone pairs on the central atom, or there's got to be different atoms bonded to the central atom. And so let's go ahead and go through this. So this first one here, now there's not really a central atom. And so let's go ahead and think about this. So we have hydrogen and we have fluorine. And so let's go ahead and think about if this is polar or not. Let's think about if this is polar. Well, there's a trick that you can use to tell if something is polar. And so if we're taking a look at the periodic table, again, electronegativity increases going up and it increases going to the right. And for something to be polar, it's got to have an electronegativity difference of at least 0.4. So how do we know just by looking at the periodic table? Well, this is going to be a general rule of thumb here. This is not perfect. You will not be able to do this with all situations, but for all the situations that you see in this class, you will be able to determine it in this way. First off, what we're going to say is hydrogen and carbon are similar. And so I'm going to put hydrogen right here because hydrogen and carbon are similar electronegativities. And because they're similar electronegativities, they're going to create a nonpolar bond. Now, the next thing that we want to consider is when we think about, for example, let's say nitrogen and oxygen. Which one has a higher electronegativity? Well, oxygen has a larger electronegativity, and so this will make a polar bond where the electrons are pulled closer to oxygen because electronegativity increases going this way. Okay, well, what about nitrogen and phosphorus? Well, again, electronegativity increases going up, and so nitrogen will have a larger electronegativity. It'll have a greater pull on the shared electron, so that will be a polar bond as well. However, what about nitrogen and sulfur? Because if you take a look, it's increasing going this way, but then it decreases going down. And so if you increase going to the right but decrease going down, you'll see that it actually sort of cancels out in a way where these will actually have similar electronegativities. And so what we're going to say is, a general rule of thumb is that anything that is on the same diagonal going down and to the right, so anything on the same diagonal going down and to the right, we're going to say that they're going to have similar electronegativities. Now, there's a lot of exceptions to this. There are many exceptions. But generally, we're going to say that these here will also have similar electronegativities. And so that is a general rule of thumb that you can use, that these have similar electronegativities. And if they're not on the same diagonal, then they're going to have different electronegativities and large enough difference to make a polar bond. So again, if it's on the same diagonal going down and to the right, they will have similar electronegativities. And then the other thing too is we're going to say that hydrogen is similar to carbon. So we're going to say hydrogen is similar to carbon, even though technically carbon is more electronegative than hydrogen. We're going to say that they're similar electronegativities. So let's go ahead and take a look here. So we're talking about hydrogen and fluorine. Here's hydrogen, here's fluorine. Are they on the same diagonal? They're not. And because fluorine is on this side of the diagonal, it's going to be more electronegative than the hydrogen. And so because it's more electronegative than the hydrogen, it is going to be a polar bond going in this direction. And so is this a polar molecule? Yes. Now, obviously it doesn't have this sort of, it doesn't have a central atom in this situation. So if it doesn't have a central atom, then all there needs to be is a polar bond. All right, so here's nitrogen. Now, how does the electronegativity of nitrogen compare to the electronegativity of nitrogen? They're exactly the same. So does that make a polar bond? No, this is nonpolar. All right, so let's go ahead and take a look at this next one here. So we have nitrogen and hydrogen. And so the first thing we want to ask ourselves is, does it have a polar bond? Well, again, if you take a look, hydrogen is similar to carbon. And so if it's similar to carbon, it should have a similar electronegativity to these right here. Nitrogen is not on that diagonal though. So that means that nitrogen is more electronegative than the hydrogen. So yes, there is a polar bond. So the first thing is yes. The first answer is yes. Oops. So the answer to the first question is yes. Now the second question, does it either have lone pairs on the central atom or are there different atoms on the central atom? Well, in this situation, the nitrogen has 3 hydrogens, so they're all the same. However, if you take a look at the Lewis structure of nitrogen, you'll see that there is lone pairs. And so this is a yes as well. And so the answer is yes, this is a polar molecule. This is a polar molecule because there's polar bonds and the central atom has lone pairs. And we can draw this here to where we have our hydrogens and then our lone pair here. And three-dimensionally, if you think about this, this is going to be a trigonal pyramidal. And so if you think about it three-dimensionally, you'll see that the dipoles are sort of pointing up and towards the middle. So they're kind of pointing up and towards the middle to where they create a net dipole. All right. Hydrogen is similar to carbon, and then here's oxygen. That is definitely a polar bond. So there is a polar bond. So number 1, yes. Number 2, does oxygen have lone pairs? Yes, it does. And so this is a polar molecule again. And you can draw the structure if you want. So all it needs is polar bonds and the central atom having lone pairs, and there you go. So in this situation, we have carbon and chlorine. Here's carbon, here's chlorine. I want you to go ahead and pause the video, and I want you to see if you are able to determine if it's a polar molecule. So the answer is it's not going to be a polar molecule. And the reason why is, yes, it has polar bonds. It does have polar bonds because carbon and chlorine have a very big difference in electronegativity. However, carbon, being the central atom, does not have lone pairs, and all of the atoms that are bonded to carbon are the same, so there are not different atoms. I'm going to go ahead and skip to number 8 because number 8 is going to make more sense with there being different atoms. And so let's go ahead and take a look here. So in this situation, here's carbon and hydrogen. So I'm going to go ahead and draw this molecule because I think it would be a good thing to see it. So there's 3 hydrogens, and then we have this fluorine here. Now, again, hydrogen and carbon are said to have similar electronegativities. However, fluorine, if you take a look here, is very different than carbon. In fact, it makes a very polar bond. And so we're going to end up having a polar bond that goes this way. And so, does it have polar bonds? The answer is yes. Number 2, does the central atom have lone pairs? Well, carbon does not have lone pairs. However, it needs to have lone pairs, or there needs to be different atoms on the central atom. And if you take a look, there are different atoms on the central atom. Look, we've got hydrogen and fluorine. Those are different atoms that are on the central atom. So yes, there are different atoms on the central atom. And so this ends up being a polar bond. And the reason why that is because if they were all fluorines, even though all of the bonds would be polar, those dipoles end up canceling each other out. But because we only have one fluorine in this situation, it's going to end up happening to where this dipole here does not cancel out. So I'm going to go ahead and say nonpolar and polar, and so I'll let you figure out why those are polar or nonpolar. So again, number one, must have polar bonds. Number two, the central atom must have lone pairs, or there must be different atoms on the central atom. And so if you get those two rules down, it's really not that bad. If you have any questions, email me. Come to class with questions, and I'll see you guys in class.